Okay, and we're back. So here's part 2 from the chapter reading, and we answered that. Haha, measuring mass and weight is where we last left off, and measuring mass and weight, here we go. Okay, so let me see what the question says. Oh, it's talking about the SI units. All right, let's find out what the SI units is. Well, I know what they are. Let me read to you what they are. Okay, measuring mass and weight. Measuring mass and weight. Okay, the SI units of mass. SI basically means the standard units that every country uses in science. So standard units of measurements that every country uses in science. Okay, the SI units of mass is the kilogram, but mass is often expressed in grams and milligrams as well. These units can be used to express the mass of any object, from a single cell in your body to the entire solar system. Weight is a measure of gravitational force and must be expressed in units of force. The SI units of force is the Newton, as in Isaac Newton, yes. Or Fig Newtons, if you're like me and think of food all the time. So weight is expressed in newtons. All right, so let's see what we have here. I think we answered probably one of these, right? The unit for blank is the kilogram. The unit for what was a kilogram? Oops. Okay. The unit of mass is the kilogram. So we'll write in mass for the first one. The unit for mass is the kilogram. The unit for blank is the newton. And if you go back, you can see the unit for weight. Weight is measure of gravitational force, must be expressed in units of force. The SI unit of force is the newton. So weight is expressed in newtons. Ta-da! I know you're probably thinking, but all of our scales say pounds. Yes, but in science terms, when we're doing science, we would express weight in newtons. Moving on, mass is a measure of inertia. I love that word inertia. I remember when I first heard the word inertia, especially teaching science for the first year, I was like, ooh, inertia. It sounds so ghetto-fabulous. That's what I would name my first kid. So I was going to name my daughter Inertia. And so she'd be like, in school, what's your name? Inertia. I still love that one. I might have to have another child just so I can do that. All right, here we go. Oh, so the rest of this page talks about the difference between mass and weight. So you see here, you have, and I'm not going to go through it because I don't really need to, all the things that talk about what mass is as compared to weight. Probably do a little bit something more with this tomorrow, so it's just so that you know the difference between the two. If I had some triple beam balances, and I don't know if the school does, we'd actually do a lab with the triple beam balances so you can measure the mass of an object, and we use a spring scale to measure the weight of an object. You've probably used spring scales before. Grocery stores, measuring fruit and vegetables and things like that, those are done with spring scales. All right. Oh, here's that bathroom scale thing I was talking about, about pounds. Let me read this for real quick. Mass, weight, and bathroom scales. Ordinary bathroom scales are spring scales. Many scales available today show a reading in both pounds as common. Wait a minute, let me read it again. Ordinary bathroom scales are spring scales. Many scales available today show a reading in both pounds, a common, that doesn't make sense to me, though not SI unit of weight. Oh, a common, but not an SI unit of weight. Aha, that's what I was saying. In science, we use SI units, so it would be newtons. But pounds is also a common measurement for using weight, and that's why you're probably used to measuring things of weight using pounds. And kilograms, it says. How does such a reading contribute to the confusion between mass and weight? Easily. Because, again, people who are not quite sure the difference between mass and weight think it's the same thing. So let's again talk about this inertia thing, right? Inertia. Mass is a measure of inertia. Man, those potatoes look good. All right, can you imagine the amount of curly fries that would make? Here we go. Imagine trying to kick a soccer ball that has the mass of a bowling ball. Ouch. It would be painful. The reason has to do with inertia. Inertia is the tendency of all objects to resist any change in motion. Because of inertia, an object at rest will remain at rest until something causes it to move. It's also one of Newton's laws. We'll talk more about that later. Likewise, a moving object continues to move at the same speed in the same direction unless something acts on it to change its speed or direction. Mass is a measure of inertia because an object with a large mass, such as this basket full of potatoes, is harder to start in motion and harder to stop than an object with smaller mass. This is because the object with a large mass has greater inertia. For example, imagine that you are going to push a grocery cart that has only one potato in it. No problem, right? But suppose the grocery cart is filled with potatoes, as in figure 9. Now the total mass and the inertia of the cart full of potatoes is much greater. It will be harder to get the cart moving and harder to stop it once it's moving. I like to think of this as shopping at Costco. Costco has big, large carts for all the big, large stuff that they have, right? So you start filling that cart with all this stuff, it gets harder and harder to push. Once you start pushing it, it's harder to stop. So all those people that stand in the aisle at Costco, okay, please understand how physical science of inertia works. If you are standing in the aisle at Costco to get that free sample, and you see me coming with a large cart with stuff in it, I might not be able to stop that cart in time because of inertia. Inertia says once an object in motion is in motion, it likes to stay in motion unless you try to stop it. That's why I'm always like, whoa, 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 before I hit you and your kid with the cart. Just saying. All right. With that, I think we now answer the question. Okay, how do mass and inertia make it easier to pick up an empty juice bottle than a full juice bottle? Okay, so we'll make sure it doesn't talk about the juice bottle afterwards. Okay, good. Okay, so empty juice bottle and a full juice bottle. Let's read this again. How do mass and inertia make it easier to pick up an empty juice bottle than a full juice bottle? So, how are we going to answer this one? The empty juice bottle has less what? Yeah, mass. Therefore, and we'll say, therefore, less inertia. That'll work. Ah, don't know what I just did. Okay. Therefore, therefore, less inertia. Inertia. I think I spelled it right. And remember, this will go right here. The empty juice bottle has less mass, therefore less inertia. Okay, that's good enough for an answer for me right there. Okay, so with that done, make sure you write this down. Pause the video if you need to. We'll go on to the next section. I can move this. I was like, okay. There we go. The next section should be page 14, which I think is back up here because of the stapling issue I had. There you go, describing matter. Okay, so page 14, describing matter. Here we go. So let's take a look at the first question. In a game of 20 questions, the most helpful questions you can ask are about the blank of an object. Anyone ever play the game 20 questions? I doubt if you guys still play it verbally today. It's probably like with the tablets and iPods and everything else, right? All right. Begin with the reading. Have you ever heard of the game called 20 Questions? In this game, your goal is to determine the identity of an object that another person is thinking of by asking questions about the object. The other person can respond with only a yes or a no. If you can identify the object after asking 20 or fewer questions, you win. If you still can't figure out the object's identity after asking 20 questions, you may not be asking the right kind of questions. Sounds like we're getting to physical and chemical properties. What kind of questions should you ask? You might find it helpful to ask questions about the properties of the object. Knowing the properties of an object can help you determine the object's identity, as shown below. So here's two students doing 20 questions. And so she's asking, and he's answering either yes or no until she figures out what it is. Okay? So with that, we might be able to answer the first question, because if you see my notes on the side, I think I'm pointing out to you where questions and answers are. Okay, in a game of 20 questions, the most helpful questions you can ask are about the blank of an object. Oh yeah, what's that word we just talked about? Properties. Okay, and let's go back to the reading. Physical properties. Some of the questions shown above help the asker gather information about color. Is it orange? Odor. Does it have an odor and mass and volume? Could I hold it in my hand? Each of these properties is a physical property of matter. A physical property of matter can be observed or measured without changing the identity of the matter. Ooh, that's oh so important. Definition of physical property. For example, you don't have to change what the apple is made of to see that it is red or to hold it in your hand. And with that, I think we can answer question number 2. Which physical properties is the person in the picture on page 43 asking about? Oh, so which physical properties is she asking about? She's asking about odor, color, I think color, odor, and if she can hold it. Okay, so we can put that. She's asking about color, odor, and can she hold it? You can put that one in for number 2. Pause if you need to get it down, and then unpause. Okay, so now let's go here. Oh, match each physical property in column B to the correct phrase in column A and write the corresponding letter in the appropriate space. Use the table on page 44 to help you. Let's go back to the reading. Aha. Physical properties identify matter. You rely on physical properties all the time. For example, physical properties help you determine whether your socks are clean, odor, whether you can fit all your books in your backpack, volume, or whether your shirt matches your pants, color. The table below lists some more physical properties that are useful in describing or identifying matter. So, some more physical properties, like thermal conductivity. You have definition for it, the ability to transfer thermal energy from one area to another. An example, like plastic foam is a poor conductor, so hot chocolate in a plastic foam cup will not burn your hand. So then you have another physical property is state of matter. Malleability means it's able to bend. Ductility, if you can like put it into a wire. Solubility means that if it's able to dissolve in water pretty much. And density, how dense something is. So if you can see here, you can answer questions 3 through 8 with this table right here. All right, so this table right here, you can answer 3 through 8. I'm not going to do that one for you. Pause the video, do it yourself. And moving on. Spotlight on density. All right, density is a very helpful property when you need to distinguish different substances. Look at the definition of density in the table above. Density, mass per unit volume. Lead is used to make sinkers for fishing lines because lead is more dense than water. Got it. Look at the definition. I'll go back into reading. Look at the definition of density in the table above. Mass per unit volume. If you think back to what you learned in section 1, you can define density in other terms. Density is the amount of matter in a given space. So, the amount of matter in a given space. Density. Or volume, as shown in figure 10. A golf ball is more dense than a tennis ball because the golf ball contains more matter in a similar volume, almost like the same size. Okay, to find an object's density, D, first measure its mass, N, which is usually categorized by M, and a volume, V. Then use the following equation. D equals M over V, which basically means density equals mass divided by the volume. Okay, if you've already done the density column in class with me, this is kind of where I was going with this. And as you can see on the next page, you have a density column that we were doing in class, except I think mine is much cooler. All right. But with this, you can now answer the next question, right? And remember this question, and a volume for density, D means this, V stands for this, and etc. I'm rushing because I got 4 seconds for this video to end. You can answer number 9 on your own. See you on the next video.